Okay, so before we actually write notes on induction, let's actually see it in action, because once you see it in action, it's really easier to figure out what the heck I'm talking about when I'm talking about induction. So, of course, induction is charging something by not touching it. How the heck is that possible? Well, here, my friends, is an electroscope, and you have this guy up here that is attached, but of course this is not open to the element. So this under here is a closed system, and then up here is an open system. And so we have actually, I don't know if you can see, but we have this little gold leaf here, okay? And so then that's of course gonna conduct electricity very well. This steel rod is gonna conduct electricity. This is a steel ball, which is gonna conduct electricity really, really well. What does that mean? It means that electrons are free to move around this whole thing because it's all metal. And so if I bring a charged object near to the sphere, then it should make electrons in here move. So what am I gonna do? I'm gonna bring something that's charged. This is rubber. You can't usually give it a charge very easily, but you can if you have fur. So of course this only happens through friction. So I'm gonna give the rod a little bit of charge with some friction and with some rubber and fur, because it's really, really easy to give a rubber rod some charge with some fur. And then I'm gonna bring it close to these guys, and you will see, well, what do you see that gold leaf doing? It's moving up. Why the heck is it doing that? Well, this guy has a negative charge on it. Do the electrons in here like that? No, the electrons here hate that. They don't want the negative charge. So what are they doing? They're moving down because the electrons don't like that this guy has so much negative charge. And so they are trying to move away. And so what happens is the electrons move down, but of course, since they're going to move into both the gold leaf and the steel rod here, then those are going to move apart because, again, electrons are going to repel. And so the two leaves down there are becoming negatively charged, and so they repel each other. And of course, since the gold leaf can move, guess what it does? It moves. And so that is charging through induction, okay? There is a way to permanently charge this thing through induction. How do we do that? Well, of course, I'm not going to touch it with the charge object because that's just conduction when you charge with a charge object. So how to permanently charge this with through induction is I bring the charge object close, and I'm going to provide a ground. What does that mean? It means provide a path for the electrons to travel either in or out. Here, the electrons will travel out because I have a negatively charged rod. If I have a positively charged rod, then the electrons would travel into the electroscope because they're attracted. But here they're repelled, so I'm going to provide a path for them to reach the ground, and that is just going to be through my finger. Okay, and then I'm going to take away my finger, and I'm going to take away the rod, and look at that. We see this lovely permanently charged rod, object, electroscope, and that gold leaf is just staying there. Why? Because what happened was all the electrons, they moved out into my finger when I touched it, and then I took my finger away, and then I took the rod away. It's really important that it's done in that order, leaving this positively charged because, of course, a bunch of the electrons moved into the ground through my body. So that's how you permanently charge something. How do I uncharge it? I just touch it, right? Because then, of course, the electrons would have moved from my finger into there, okay? So again, really important that it's done in that order, though, that it's not. So again, when you want to permanently charge it, you bring the charge object close, you provide the ground. If I just took away my finger, or the rod first, and then my finger, again, my finger's allowing electrons to move easily. So that doesn't permanently charge it. You have to remove the ground first. So again, rod, finger, remove rod. And now it is permanently positively charged. Okay, and you could do that with a positive rod, and of course just all the opposite stuff would happen. But there you go, that is charging through induction. Okay, so let's just write down now everything we learned about induction. So of course induction is the temporary charging, because we're just using a charge rod to hold it near the neutral object, and that causes polarization within the object. Polarization is a really important word, okay? That is just when inside one object the positive charges move to one side and the negative charges move to another. Okay, so the thing is still overall the overall object is still neutral, but like one side of it is positively charged and one side is negatively charged, okay? So that's what polarization is, so important word to take note of. And then, of course, if the rod's removed, then the object remains neutral. It just has to do with the distribution of charges within the object. And then if I were to have broken that electroscope in half, before the rod was removed, like take off the top part of it, then that gold leaf would have remained away. It would have been permanently charged at that point. Okay, and so of course we use the electroscope to detect that charge. And so when we bring a positively charged rod, that will attract electrons to the head of the electroscope, and then the leaves will be positive and they'll repel. So it'll look a little something like this. So of course, all the electrons will be attracted to the positive charge in the rod, and so they'll all move up, right? The electrons will move up into the sphere, leaving these leaves down here net positive charge. Okay, so again, the whole electroscope, it does remain technically neutral. It's just now the sphere is more negative and the leaves are positive. So that's, again, the polarization there, where one part is more negative and one part is more positive. Okay, and then what we saw was a negatively charged rod repelling the electron. So that's what we saw with the rubber when I was doing the example. So again, the rubber becomes negatively charged, and then that means that the electrons are going to move down to the leaves, right? So here the electrons are going this way because they're trying to get away from this negatively charged rod, and then of course the sphere became positively charged. And that's what actually worked in the demonstration that I just showed you, okay? And then the greater the amount of the charge on the rod, the larger separation of the leaves. So again, the more negative charge you give this, then the further these leaves are going to separate from each other, right? Because that means that more and more electrons will be repelled from the very negatively charged rod, okay? And then permanent charging, which I did go over again, and that is when we hold the charge rod near to the neutral object, cause that charge separation, then you ground it. Remember, that was me just putting my finger there because, again, that finger, that allows electrons to freely move to the ground, or electrons from the ground to freely move into the object. And then you actually have electrons moving in and out of the object, and therefore it's actually becoming a charged object. It's still not through conduction, though, because the charged object never actually touches the neutral object. So that's really, really important to note. Okay, and then you remove the ground and then remove the charged rod. Remember, these need to be in this exact order. Because if you move the charged rod first, then the object will just remain neutral because the electrons that have left will just return back to the thing. And they'll be like, oh, never mind. The reason that we left in the first place, there's no reason for that anymore. So we'll just go back in. Okay? And so just keep in mind, have to remove the ground first. So then the lack of electrons that are now in the electroscope, it's stuck that way, and no more electrons can move. Okay, and so of course we have a different kind of thing will happen if you have a positive rod versus a negative one. Okay, so of course if the positive, so we start with the neutral electroscope. And so that's when the leaves are basically together, although I'm not going to quite draw them that way just because then you wouldn't really know. And then, of course, this is neutrally charged, and all charge is sort of balanced throughout the whole thing. And so as soon as you bring that charge near, then the electrons are going to move then the electrons are going to move down. But instead of just doing that, so I bring a positive charge near, we know that that's going to charge or cause the electrons to go to the head, except for what if I provide a ground? To provide a ground, I draw it like this, where I just draw this and then I draw like 3 lines here. And so that means it's grounded, okay? And so that's the grounding. Just means whatever grounding is, it just means that electrons are free to move in or out of the electroscope from the ground or to the ground. Okay, so what are electrons going to do here? Well, they're going to be attracted to the positively charged rod. So here, the electrons are going to move into the electroscope, okay? Okay, so electrons are moving into the electroscope because, of course, they are attracted to that positively charged rod. So this is going to have an overall negative charge. Now, I draw it like this, and people tend to forget that there are still positive charges in here. Obviously are. We're not fully getting rid of, like, all protons because, well, then we wouldn't have metal anymore. So remember, there's still positive charge in here. It's still the same amount of positive charge. It's just far more negative charge. Right? So there's still positives in there, but it just becomes overwhelmingly a negative charge thing because the extra electrons are moving into it. Okay, and then of course we remove the ground before we remove the rod. And so again, what happens is those electrons that moved in there are now stuck. Okay, and so this is just super, super negative. Okay, remove grounding. And now the electrons are stuck there. We still have this positively charged rod, though, near it. And again, the electrons are still very attracted to that positively charged rod. So then the leaves actually might not be as far apart right now because they're still slightly more neutral. Okay, because it, again, does have extra electrons, so all the extra electrons are hanging out here in the sphere, so this guy's really, really negative. But as soon as you remove that positively charged rod, then the leaves go just way apart. And that is the exact sound they make, obviously, because then what do the electrons do? Because this here is way more negatively charged before that. And then what do the electrons do? They're trying to spread out as evenly as possible once there is no positive charge that they are attracted to. Okay? And so there we go. Now our electroscope is permanently negatively charged. But keep in mind that this is still charged through induction. Even though there was contact, the ground, remember, is a neutral thing. So that's just allowing electrons to move. So technically this is still through induction because the actual charged object, the rod, never actually touches the electroscope. So it's still charging through induction and not conduction. And then you can do the same thing with the negative rod. So this looks very, very similar. But again, here, instead of electrons moving in, they'll move out. So again, start with your neutral electroscope, where we have even number of positives and negatives, right? And they're nicely spread out everywhere. So that is step 1. Okay, so of course, after we have this neutral electroscope, though, we bring the negatively charged rod near to it this time. So on our second step, we bring the negatively charged rod near, because the last time we brought positive near. And then, so what does that make the electrons want to do? Well, initially, then the electrons are going to want to move down into the leaves, but then I'm going to provide a grounding, okay? And again, what are the electrons going to want to do this time? Well, here, they're being repelled by this negatively charged rod, right? So guess what? In this situation, my electrons are actually going to move out of the electroscope into the grounding, leaving this what? A net positive charge here because all the electrons are leaving. So instead of going down into the leaves, providing that ground allows the electrons to actually fully move out of the electroscope, because they want to get out of there. Okay, and then of course in step 3, we always remove the ground first, right? We never remove the charged rod first, because then the electrons would just go right back into the electroscope. So we move the ground, and then what has happened, this is now a positively charged electroscope, right? So there we go. We have a positively charged electroscope. Remove ground. Always do that first. And then, of course, when we bring the charge away, because right now there's still excess electrons down here, right? Because they're being repelled by the negatively charged rod. And so then now when we bring the rod away, the leaves diverge even further away, because again, now the electrons try to spread themselves out as much as possible, which here, there's actually not enough electrons, so these leaves become even more positively charged, and they just spread right out, okay? And so then we have a positively charged electroscope. And there we go. That is charging through induction. Now, one good thing that we can use induction for is to determine the charge of an unknown rod, or really just the charge of an unknown object. So we know an object has a charge, but we're not sure what the charge is. So how the heck are we going to do this? Well, we induce a known charge in an electroscope. How do we do that? I just showed you how to permanently positively charge an electroscope and negatively charge an electroscope. So you induce that known charge on the electroscope. You bring the unknown charge near. And of course, if the leaves converge, if they come together, we know the charge is opposite because it's allowing that charge to move, or the electrons to move towards or away, then therefore neutralizing the leaves. If the leaves diverge even further apart, then it must be the same, because again, that charge is either repelling the electrons, making the leaves more negative, or it's attracting the electrons, making the leaves even more positive, okay? So, for example, if I wanted to determine the charge of a plastic rod that was rubbed with cotton, well, first I'm gonna maybe use a glass with silk to create positive glass, because then I know I will create a negatively charged electroscope. Okay, so we're going to use the ground to induce the negative charge in the electroscope, and then you bring the plastic near, and the leaves will diverge, and the rod will be negative, of course, because we know plastic is always negative. Okay, so that is how you can determine the charge of an unknown object, is again by looking at if the leaves diverge even more, then it's the same charge. If the leaves converge, i.e. come together, then it's an opposite charge. Okay, so so that's a really useful tool for induction. Conduction, super easy. Don't really have to go into that a lot. It's basically two charged objects touch each other. Electrons transfer from one material to the other when the objects are touching. Super easy. Like conduction compared to induction, way, 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 way easier. So, with conduction, again, electrons are transferring from one material to another. So an example of this is if a pith ball is suspended by a string, and then we have a negatively charged rod brought near, then it'll create charge separation on the rod and the pith ball, okay? It'll track the pith ball initially, and then, of course, that's when we'll actually have, once those objects touch, electrons will actually transfer, and then they'll both be negatively charged and they'll repulse. So let's actually just draw a diagram because it's way easier. So again, a pith ball is just like a tiny ball, and it's like it has a metal coating on the outside, so it's actually really, really light, so it's easy to move. That's why we often talk about pith balls, because they just move so easily. So if they have like any sort of charge around them, they will move right towards the charge. So say this is a negatively charged rod. Why will the pith ball move? Well, again, it'll create that, what's the word? Polarization, because all the electrons are going to move further away from the negative charge. And so we'll have this charge separation or polarization, which is really important buzzword to know. Okay, charge separation or polarization. Just meaning the charges are spreading themselves out here, okay? Except for it's still overall neutral, right? The pith ball. But then guess what? The pith ball's actually, there's nothing stopping it from actually touching the rod. And so it's going to move right towards it, right? It's going to just go boing, and it's going to actually touch the negatively charged rod. And then what's going to happen? Well, this has extra electrons on it, and the pith ball has a metal coating, so it is definitely a conductor. So guess what electrons are going to do? They're going to jump from the rod to the pith ball. And so then we have an electron transfer from the negatively charged rod to the pith ball, of course, making the pith ball a net negative charge. And then what happens? Well, now we have two negatively charged objects, because they're probably not going to share the charge evenly, because the rod is way bigger than the pith ball. And so therefore, they're going to be repelled afterwards, because of course the pith ball is like, I'm negative now, and you're a negatively charged rod, and so I don't really like you anymore. So finicky, those pith balls. And so this is negative. It's not as negative now, right? But still, it's still overall negatively charged rod, because the pith ball is so much smaller than the rod. And so then they're going to be repelling, because they're both negative. And that is charging through conduction. And there we go. That's that, folks. So induction, conduction, that's how we charge through both of those. And then, of course, when you have an insulator, how do you charge? Through friction. And, yeah.